7. This section 1.4 is actually the start, the beginning of calculus 1. So all the stuff which I covered so far, that's still pre-calculus and algebra, mostly algebra and some geometry and some graphing. And so we are now going to start calculus, okay? And I'm planning to give the test very soon here. It's coming up, so I don't know how much we can cover, but hopefully we'll be able to cover most of it, okay? So section 1.4, let's start. Tangent lines and rates of change, example 1. Find a tangent line to the curve y equals x squared at 1, 1. Okay, so let me just magnify this page. Is everybody with me? Sorry about that?
Yes.
Yes. Okay. So now let's start section 1.4. Find the tangent line to the curve y equals x squared at 1, 1. So I want you to understand the grammar here. So whenever we talk about a tangent line, then it is always a tangent line to a curve at a point. So tangent line is, in order to talk about a tangent line, we need a curve and we need a point on the curve. And so in this case, our curve is going to be y equals x squared, and the point of the curve is 1, 1, and we want to find the tangent line. Now note that I did ask you to find the tangent line, but the question is, the obvious question is, well, what is the tangent line? What is the tangent line? Tangent line, what is it? You know what a tangent line is? Well, this is a slightly difficult concept. It is now a calculus concept, so what we want to do is, we don't know what a tangent line is, but roughly what a tangent line is this. A tangent line is basically, in this case, if you have a curve like this, let me see, a curve like this, then what is the tangent line? Let's say here's the point right here. So what is the tangent line to this curve at this point? Now, the tangent line is basically the linear behavior of that curve near that point. So let me explain to you. Basically, the official definition is really this. The definition of a tangent line is really this right here, but you know what, if I give you this, then you may have a hard time what this means. It's not clear what that is. So what I'm going to do is, first, I'm going to roughly, tell you what a tangent line is, and then we will slowly learn the definition of tangent line. So what exactly is a tangent line? The tangent line is basically this. So here's the point 1, 1 here, and this is the y equals x squared. Now, if we magnify this part of the curve, now here, class, if we magnify this part of the curve, what kind of a shape will this curve be? Now, if you look at this entire curve here, the entire curve is like this. It's kind of a smiley face, right? Like that. But if we just magnify this little part of it infinite times, what do you think this guy would look like?
Straight.
That is, magnify this part of the curve right here infinite times. How will that guy look like?
A line.
Straight.
Yeah, that will look like a straight line. And so, basically, if we look at the line there, that line right there, that line which is almost describing the behavior of that curve near that point, that line is called a tangent line. So the concept is a little bit more advanced. It cannot be explained in real simple terms like geometry, like terms in geometry, because it does involve what we call the limit. So we have to understand what this limit is. So basically, when you magnify this part of the curve 100 times, then if you magnify this like this, magnify this 1,000,000 times, then in this circle right here, the curve is going to look like this. It kind of looks like a line. And that line is what we call the tangent line. It is the linear behavior of that curve near that point. So to illustrate that, what I'm going to do is, I think now this is a good time where I can actually go to the calculator and go to the graphing calculator. But before that, basically this. Okay, how to get this? Well, this right here. Okay, all right. So what we have is, I can go there. What we can do is, how about if I do? Okay, so now the question is, how do you get this? How do you get this line right here? How do you get this line? The question is how to get that line, right? So what I want to do is I would like to go to the graphing calculator. And so this is now, let me clear this now. And then I'm going to go to the graphing calculator, and our favorite website, well, my favorite website is decimals.com. You can go to any website you want. And so now what we have is we have x squared. Yeah, so I have done all the preparation right here. I didn't want to spend time all this typing all this. All this I prepared to what? To do this. So this is the curve y equals x squared. And then yeah, that's it. And then here we would like to find the tangent line to this curve at the point 1, 1. So now a equals 1. Did I say a equals 1? Oh, a equals 1. No, a is not right now 0.1. It's now 0.17. So let me now say a is equal to 1. And also I'm going to now label this guy. I'm going to plug in this point. This is point on there. Where's the point? Label the point. Oh, there we go. There's the point 1, 1. Right there. So here's the curve y equals x squared, and y equals a squared, and I mark a comma f of a, and I let x equals 1. So this point right here is 1, 1. That's a comma f of a, 1 comma f of 1. This is 1 comma f of 1, and f of 1 is actually 1, because in our case, f of x is x squared. So this is the curve y equals x squared. Okay, so now what we do is, now what I'm going to do is I'm now going to pick another point on the curve. Another point on the curve is now the green point, this guy. Where's the h? H? Where's my h here? H is 1 comma. Wait, where's my h? No, this one here. Is it h far away? Where's my h here? Well, h is 1.75. I see. This guy's too high. Now we see the h. H was so far away. Okay, that's fine. Okay, so what we have is this point right here. So we have this. So if you look at this graph here, we have the curve y equals x squared, and we have the point 1, 1, and then we have another point here, and then it's marked in green. So 1, 1 in our case is a fixed point, 1, 1. I fixed it, a equals 1. And however, the h is actually flowing around. So I can actually move this point here and there like this. And now what we want to do is, we are now going to connect the 2 points, these 2 points here. And so I got the slope. Slope is m. And then I'm now going to mark this one. So this now red line. What is the red line? Red line is now the line connecting the 2 points on the curve. And now what I'm going to do is, this point right here in red, this green, I'm going to move this along, like this. So now the question is, what is a tangent line? Where's the tangent line? Well, tangent line, this is not the tangent line. So in order to get the tangent line, what should I do? I have to now bring this green point towards the purple point, 1, 1. So this green point, I'm going to bring it closer and closer. And then I'm going to do this. And then now, this green is so close. See this green point right here? Now the green is now, the green point is only 0.05 away. Right now, the value of h is 0.05. That h equals 0.05 means that the green point and the purple point, they're only, the difference in x value is only 0.05. They're very close. So as you can see, this red line is now almost a tangent line. But now what I want to do is bring this red closer to 1, and then 0.2, and now 0.1. Look at that. Now, do you see this red line? This red line is almost a tangent line. Practically, if you just look at it, it is a tangent line. That's what we call the tangent line. But note that if you let this green point coincide with the purple point, where h is equal to 0, then now we don't get a line. If you have 1 point, is there a line? No, there's no line. There's no line. We can't get the line. So we have to make this green point be another point. So if you let this h be 0.1 like this, then we get this and we get the line. So This red line, that's what we call the tangent line. Well, again, this is not the tangent line. European tangent line, the difference must be really small. Really small. In this case, how about if I let the h to be 0.001? Really small. But essentially, in order for this to be tangent line, this difference should almost be 0. But as I said, can this be 0? No. If it is 0, so let me just type it in 0 here. If it's 0, then as you can see, there is no line. So this is the dilemma. If it's 0, we cannot get a line. There's only one point. But if you make it like this, then we get a secant line. But practically, when this amount becomes very close to 0 like this, then essentially this is what we call the tangent line. So the red line, that's what's called the tangent line. So we pick a point, and we have another point. You know what? We have another point, and let this green point approach the purple point. And as you get closer and closer, as you get closer, note that the red line is not changing that much. See, from here, as I move the point, the green point towards the purple point, does the red line really change that much? No, the red line does not change that much. And then as you get closer and closer, the red line is now called the tangent line. Now, does that make sense? Okay, so now let's figure out what this is. Now let's try to figure out the slope of this line. So we want to now find the slope of this red line, which is a tangent line. And so now let's go back to, and now let's do some algebra here. Okay, so how do you do this? Example 1. Find the tangent line to the curve y equals x squared at 1, 1. So let me now do this here. This is what I'll do. Annotate. And then we have a curve like this. And then there's the point 1, 1. So we want to find this line, right? Or we want to find this line. But note that with one point, we cannot find the tangent line. So we pick another point on the curve. How about if we pick a curve over here? We will pick out a point right here, and this will now be called, this, by the way, 1, 1 is basically what? 1, comma f of. Oh, wait. Did you have a question?
7.
Oh, sorry. F comma 1, f of 1. But in our case, f of x is x squared. In our case, in example 1, what is our f of x? F of x is x squared. And then now we take the point right here, 1, 1, which is f, 1, f of 1, and now we pick another point here. That's 1, 1, with another point on the curve, and that point we will now call this guy 1 plus h, comma f of 1 plus h. That point is called 1 plus h, comma 1 plus f of h. Now, what is the slope of the line connecting? So what we do is, first, what? Pick 2 points on the curve. What is the first point? What is the fixed point? The fixed point will be, the fixed point is what? Is 1, comma f of 1, comma, or is 1, comma f of 1, which is equal to 1, 1 in this case, because f of x is x squared. And then now, we will now pick the moving point. What is the moving point? We will call this guy 1 plus h, comma, f of 1 plus h. And f of 1 plus h is, of course, 1 plus h squared. Let's talk about the noise here. I think somebody's cutting grass right outside. Now, what is the slope of the line? Slope of that line. Slope of the secant line. Now, what is the secant line? Now, do all of you know what a secant line is?
Yes, I believe it's the inverse of cosine, correct?
Ah, so yeah, you know what? However, that is a different secant. Okay, so yeah, sorry. Yeah, you're right. But that is on this secant right here. Yeah, the question is secant related to the secant in trigonometry? And the answer is, I think it's no. And how about the tangent line? You know the tangent line? Is this tangent line related to tangent in trigonometry? I think there might be some relations because I don't know where these terms are coming from. But let me tell you, the term tangent line has not much to do with tangent. Okay, so I don't know. Again, I don't know history behind this. I think there might be some relation, but you know, it. You know what? There is no obviously a related. There is no obvious relation here. So this tangent line is not related to tangent in trigonometry, and the secant line is not related to the secant in trigonometry. I think there might be some relation historically, but again, they're not the same term. So let me tell you what they are. So let's say, how about this? If you have, let's say, if I have a circle like this, let's say if I have a curve like this is actually an ellipse, and now this line right here, this kind of line right here, this kind of a line right here is called a tangent line. So what is a secant line? A secant line is basically any other line which intersects and which is not a tangent line. So like line like this, let's say called brown, and then then draw a line like this, and then line like this. That would be a secant line. So here, if you have a point right here, then the tangent line would be what is the tangent line? The tangent line would be like this. That's the tangent line. The tangent line represents the linear behavior of that curve near that point on the curve. So if you look at the point on the curve, the point on that curve, then the curve and the line, they kind of look alike. So near that point, the curve kind of behaves like a line, and that line is called the tangent line. Now, what is the secant line? The secant line is basically a line like this. In our case, it's basically a line which connects 2 points on the curve like that. That's called a secant line. So this is a secant line. This is secant line. Secant line. And this is a tangent line. Okay? Again, what is a tangent line? Tangent line is the behavior of the curve, the linear behavior of that curve near that point. So near that point, if you magnify that part of the curve infinite times, that kind of becomes a line. That line is called the tangent line. And any other line is called the secant line, basically. So we now, in this case, we want to get the tangent line. But in order to get the line, we need 2 points. So we now pick another point, which is this point right here. This point right here. And then we have this point right here, and therefore we are now going to connect those two. We're going to connect those two, and then we get a line like this. And then now what we're going to do is we want to find the slope of the secant line. What is now the slope of the secant line? The slope of the secant line is going to be this. Let me now erase all this. We don't need all this. Therefore, what is the slope of the secant line? Slope of secant. What is that equal to? That is now the slope of the secant is going to be the slope of the two lines of the line connecting those 2 points, and that will be what that will be f of x plus 1, f of 1 plus h minus f of 1 over 1 plus h minus 1. This is the line. So the slope of the line, the tangent, the slope of the secant line is this right here. This is not the secant line. This is the slope of the secant line, or slope of the secant. It is the slope of the line connecting this point right here and this point right here. So in our case, f of 1 is equal to 1, of course. But it is a line connecting those 2 points, and this is what it is. f1 plus h minus f1 go over, and the 1 plus h minus 1, and that's this right here. So now, all we have to do is simplify this. If you simplify this, what do you get? And then, by the way, in this diagram right here, we assume that h is not 0. If h is 0, then the second point becomes the first point, and we really don't get any line. We only have 1 point. So h cannot be 0 here. So now what we do, now we do this, h, and then now what is 1 plus h, f1 plus h, and that will be 1 plus h, or 1 plus h, pointing a square, and then minus, what is f1? f1 is actually 1. So we get this. So what is it equal to? What is it equal to here? Oh, that is equal to, okay, so now that's that. Okay, so let me just leave that there. And now what we want to do is, now finally, we now want to find the slope of tangent, a tangent line. So what is exactly the slope of the tangent line here? The slope of the tangent line is basically, the slope of the tangent line right here is basically equal to the limit, and I'm going to explain what that means. That will be the limit of the secant line, and that will be this right here. So this is f of 1 plus h minus f of 1 over the 1 plus h, the minus 1. By the way, we do take the slope of the secant line there, but we cannot let this h be a number. As long as h is a specific number, we don't get a tangent line. We get a secant line. So that will be the slope of the secant line. But now, in order to get a slope of tangent line, what do we have to do? Well, we have to let the second point approach the first point. And so we really need a point which is really close by, such as this point right here. You have to make it really close. So I already showed you this on the calculator. And so we now, let's say this, we now want this limit at h, limit of this expression at h is approaching 0. So what that means is we want to see what happens to the expression right here as h is becoming small and small. So now what is this here? This is equal to now the limit. H is approaching 0. Now what is this expression here? This expression is going to be 1 plus h squared. So this is 1 plus h squared. So let me write 1 plus h squared, and then what, minus 1, and then over, and this is 1 plus h, and then what, minus 1. This right here. And I need to put a square here. And what is this going to be? This is now going to be the limit. H is approaching 0. What is this here? This is now going to be h in the denominator. And what is the numerator? The numerator is going to be 1. The numerator is 1 plus 2h, and then plus h squared. So what we have is now we have 2h. H times, we have now what? H times. If you factor out the h here, let me skip a step. So we have h and then times of 2 plus h. You get this. So if you simplify the numerator, we get 1 plus 2h plus h squared, then minus 1. So 1 minus y is gone, and so we get 2h plus h squared. And you factor out the h, and now we get h times 2 plus h, and over h. And now we let this h up to 0. Now we have to understand what this limit is here. What we really mean by this limit, h is approaching 0, we want to know what happens to this value right here. So note that when h is equal to 0, this becomes undefined. So we don't want this h to be 0. So h approaching 0 means it is really getting really close to 0.
Did you hear it? I was tired.
We want but really close. But note that h is not 0. H is not 0. When h is 0, this is undefined. So what we get is this. You know what? Let me erase this part right here. I think we need. Oops. I cannot erase that. So this right here. So what happens is this becomes what? Undo. This right here, I have to erase this part. Erase. Okay, so this is now equal to this, is equal to now. So let me write this equal to, and this is now equal to limit. Limit what? This is now 2 plus h. Now what is that? That actually becomes 2. Oops. It should be limit. Let me write limit here. Limit. And then h is approaching 0. The reason why we could reduce this h and this h is because this h is not 0. We assume that h is not 0. H will be a very tiny amount, like 0.001, but we assume that h is not 0. So therefore reduce it. Now when you look at this expression 2 plus h, and then h is getting close to 0, what does it really approach? What value will this guy approach when x is approaching 0? And it is actually approaching 2. It turns out the slope of the tangent line is actually exactly 2. Now, is it approximately 2 or exactly 2? Right now, it's not clear to you, but it turns out the slope of the tangent line happens to be exactly 2. So this is slope. So therefore, what is the, so now we come here. Now let me write down the line equation. So therefore, what is it? Therefore, let me write. Therefore, slope is 2. Slope is equal to 2. And we have point 1, 1. So therefore, what is the line now? Therefore, line. What is the tangent line? The tangent line is going to be now. The tangent line is going to be. Oh, you know what? And I'm running out of space here. The tangent line. Let me just write the tangent line right here. And the tangent line will be over here. Or let me just write over here. That will be y minus 1 is equal to 2 times x minus 1. And then when you simplify this, we get y is equal to 2x minus 1. That is the tangent line. Now let's look at this one more time. Let's look at example. Example factor. Now note that in this case, if you look at example 1, we name the other point 1 plus h, comma 1 plus h, f1 plus h. That's how we named it. We call this point what? We call this point 1 plus h, comma 1, comma f1 plus h. The difference in x value is h. So when you find these tangent lines, this is how we name the other point. This is the moving point. The fixed point is 1 to 1. Now the other way of naming this other point is this. Sometimes we don't name this 1 plus h, comma f1 plus h. We actually name it like this. T. We actually name it. We actually name it as t, comma f of t. Sometimes we name it this way. So how about if you name it that way? How will this change? If you name it that way, then how does it change? Then this is how it works. Then what is the secant line? The secant line is going to be f of t minus f of 1. You know what? Let me write it this way. How about this? Let me write it this way here. The slope of secant. Slope of what? The slope of tangent is equal to now is going to be this. It's going to be the limit of the secant. In this case, the limit of the secant is going to be this. It's going to be f of t minus f of 1, and then divide by t minus 1. Sometimes we name it this way. Now, if we name this point t, comma f of t, and we want to let this t, comma f of t approach 1, comma 1, or 1, comma f of 1, then what should this t approach? This t, comma f of t is a moving point. So we have to let this point be closer to this point, 1, comma f 1, and therefore we can see that this t has to approach this point. T must approach 1. So if you name the other point like this, t, comma f of t, to get the slope of the line connecting the 2 points, what do? We get this. That's t minus f1 over t minus 1. And now, in order to make this point, the moving point, get closer to the fixed point, the fixed point is 1, 1, what do? We have to let this AC approach 1. Note that in this case, H has to approach 0. Because in this case, when H is approaching 0, then this point will approach that point. If you name it this way, then T must approach 1, so we get this. So we end up getting this. So what is this? This is now equal to the limit. T is approaching 1. What is this here? This is actually going to be T minus 1. And then what is the f of t? F of t is t squared. And then minus f of 1. F of 1 is 1. We get this. So now in this case, what we do get is now here, I'm running out of space here, but let me just continue. This is the limit. Let me call this now t is approaching 0. What is t is approaching 1? What is t squared minus 1? So t squared minus 1 is equal to f of t. The t squared minus 1 is f t minus 1 times t plus 1. Then over what? T minus 1. This is what we get. Then now, what is that? What is that? Now, when you plug in t equals 1, we get undefined here. So once again, when you say t is approaching 1, again, let me write this down. When you say t is approaching 1, we are saying that t is closer to 0, t is closer to 1, but t is not 1. T is close to 1, but it's not 1. Because if t equals 1, then we only get 1 point. And then we cannot get the slope. So it must be another point. But you have to make sure that these are getting closer to 1. So we get that, and so when you do that, so now what we do, we can reduce this t minus 1 over t minus 1. Because t is not 1. Again, t is not 1. And so what we end up getting is the limit. And then we do get this t plus 1. And then t is approaching 1. So note that I'm really running out of space. I'm sorry about this. This is bad, board management. And anyway, the answer comes out, since t is approaching 1, we actually get 2. Same 2 as this guy right here. So it doesn't matter how you name it, you will get 2. So if the slope is 2 and we have the point 1, 1, the tangent line must pass through the point 1, and so we get the line, and so we get the line right there. That's how we get it.
Could I ask you?
Yes, what is the question?
So the limit is basically like telling us what like the lowest value of or what the value of the answer should be above, pretty much.
No, we are trying to see the value is approaching. So basically when you say this, so it says here when you look at when you have this t, okay, so let's say how about what we have is we have t minus 1. And then we have basically, how about this? Let me open up a whiteboard. So basically, when you have like a t squared, and then minus 1 over t minus 1, and then the limit is t. Now, by the way, this is the topic of section 1.5, by the way. Okay? So we are going to continuously study limits. This is not the only section. Again, section 1.4 is the beginning, 1.4, 1.5, 1.6, 1.7, and up to even 1.8. 5 sections cover the topic of limits. So basically, in order to figure this one out, we have to understand what this means. What this means in this case is t is approaching 1. We want to know what happens when t is approaching 1.
My enrollment's
So what we
working
have is
now.
we have the t,
My
and we
enrollment's
have
working now.
this is the expression, t squared minus 1 over t minus 1. But if you look at t squared minus 1 over t minus 1,
Where is your
this
colleague,
is
you little
essentially what?
nudist?
This is
He's a
essentially
nudist.
t plus 1. Again, this is t plus 1, because this is t minus 1 times t plus 1, and then over t minus 1. So this is essentially t plus 1. So what you're saying is, oh, excuse me, pal. Sorry. So I have some problems here, so that's why I have to just answer the phone. Okay, so let me just continue. So we have this here. So what we are really trying to do is this. See what? It's basically the idea is this. Idea is, so let me just draw these lines here. Two column lines. Now when t is approaching, let's say 1. So let's say what happens what is the value of this expression when t equals 3? So let's do that. When t equals 3, what's the value? This guy's 5. Essentially, this is basically what? It's t plus 1 when t is not 1. And this is equal to t plus 1 when t is not 1. So let me write this down. When t equals 1 when t is not 1. T is not negative t is not 1. It's essentially this. So this is basically t plus 1 when t is not 1. So when t equals 3, what is that expression? What is the value of that expression? T squared minus 1 over t minus 1. That's 5. What happens when t is equal to what? Let's say 2. Then that's 2. The t squared minus 1 over t minus 1, which is basically the t plus 1, is basically 4. So what happens? When now? We want to let this t approach what? Yeah, approach 1. So can you do how about? What happens if it's actually 1? What happens when it's actually 1? This guy's actually undefined. It's not defined. So we don't want this. When t equals 1, this guy's actually undefined. It's not 2. It's undefined. But we are not interested when t equals 1. We want to know what happens when t is approaching 1. So now in this case, what we want to do is now let's pick a point which is closer to 1 than 2. So now, how about if we now plug in 1.1? How about if we plug in 1.1? Then what do we get for this expression? T squared minus 1 over t plus 1. T minus 1. That will be essentially t plus 1. T plus 1 when t is not 1. So therefore, this will be what? What will this be? What will this be? You know what? Sorry, messed up here. I'm all wrong. I've been hurrying so much here, I made a mistake. So what I'm going to do is I'm going to, what is it?
Because it doesn't equal 5, right?
Yeah, it's not 5. What is it?
Okay, that's what I was looking at. That I was kind of confused.
What is when t equals 3? What's the value of this expression? It's 4. And then this guy's actually 4 because it's t plus 1. So we get 3. So when you plug into this expression right here, we get 3 and we get 4 and we get 3. Now what happens if you plug in this t equals 1.1 into this expression? T squared minus 1 over t minus 1. Well, that is essentially t plus 1. T equals 1 plus 1. T is not 1. So this guy is actually 2 plus 2.1. What happens if t is equal to 1.001? Now note that t is not 1. This is 1.001, which is not 1. If t is equal to 1.001, then what is the value of this expression right here? Well, that value of that expression will be basically t plus 1, which is 2.001. So what happens if we plug in 0.00001?
It's the same thing.
0.00001. You get that. So now from here you can kind of guess it. As the value is approaching 1, now I'm not saying that we should plug in 1 here, but as these guys are approaching 1, and now look at these guys right here. These guys, just look at these guys, don't look at the function. What do you think these numbers are approaching? What are these numbers approaching? they're approaching 2. You see this? These guys right here are approaching 2. But this undefined, this is f of 1. This number 2 right here, this number 2 is not f of 1. This is the limit. You know what? Right now, let me not say this right now. Let me erase this. Let me erase this part right here. Eraser. Let me write this. So this should be undefined. This is still undefined. But anyway, these guys, so that as these guys are, as t is approaching 1, as t squared minus 1 over t minus 1, they're approaching 2. So when you actually plug in t equals 1, the problem is this actually becomes undefined. But this is basically undefined right now. Undefined. So in this case, what is the value we're looking for? The value we're looking for is actually this guy. We are looking for this number. This is called the limit value. This is called the function value. In this case, this becomes 2. So that's why we have only times already up here, the limit, and the what? T is approaching 1. And then t minus 1, and then t, since you're running out of time, I cannot continue here, but anyway, t plus 1 here, and then we have, the writing is unclear. Just give me a minute to finish this argument here. So in this case, what we have is this. So let me just finish the argument, sorry. We're going overboard again. So what we have is, this is now t minus 1, this is t minus 1, and then times t minus 1. T minus 1. Now note that in this case, once again, when you say t is approaching 1, we are saying that t is not 1. Oops, small t. This capital T, this is t, small t. So therefore, because the t is approaching 1, we are still assuming that this is not 1. So therefore, t is not 1. I know this is a bit confusing here. We are saying that t is not 1. So when you now look at the next step here, what is this here? This is the limit. This is the limit, and then this is now the limit of
right?
t plus 1.
Every day?
T.
A couple times a day?
It doesn't write. Oops, sorry, it doesn't write.
You need to do the flush.
You know what?
The flush and gargle with
T
salt
and then
water
plus
and
1.
iodine.
And then as
You
t
just
is
start to get
approaching
the
1,
virus
what does
particles out of your
approach?
nasal
As t is
passages.
approaching, what is happening to t plus 1? And that t plus 1 is approaching 2. And this is the limit, but the language is we say equal to 2. The equal means it's targeting 2. It is getting closer to 2. But the way we write it, we write equal to 2. So these guys are approaching 2. So we say that the limit is 2. Now 2 is called the limit value, and this undefined, this is called the functional value. And more will be coming up. So you don't have to understand everything right now, but this is called the limit. Okay? So you know what? Since the time is up, I'll stop here. I guess tomorrow, I think we'll have to go through a lot of the stuff. Okay? And hopefully we can have a test on Wednesday. But tomorrow will be a long day. All right? Okay. All of you have a good day, and I will meet you. We'll have a Zoom meeting tomorrow at 8 o'clock. Bye, everyone.
Fine, thank you.
Did you say test or quiz on Wednesday?
Thank you, Professor.
Bye-bye.
Are you still here, Professor?
Yes, I'm here.
Do you have a quick second for a question about the mid? I know you went over. I just have a quick question because I still was kind of confused. I just still was really struggling with number 4. I just really don't get it at all.
Well,
In the
before
midterm.
if you want to understand number 4, you have to understand what we call the factor theorem. So did you have a chance to study the factor theorem?
I don't remember it off my head, but that's what you need to solve it.
So you need to know the factor theorem in order to do what? You have, I don't know whether you don't have to know the name factor theorem, but you have to know the content of factor theorem. So let me tell you what the factor theorem is, and then you can ask me questions from there. So let me first write this down. What is a factor theorem? Okay. So let me first explain to you first. you need to know this, otherwise you cannot do number 4. Okay, but you might know the content of this factor theorem. You may not just know the name. It's not important that you know the name, but you have to know this factor. Okay? So you have to know this formula. Okay, so let me just explain to you. So where is it? Let me explain to you let me use the black color. So what is factor theorem? Factor theorem is this theorem right here. So if polynomial let P how about let this P of X or F of X doesn't matter. P of X be a polynomial. If P of C is equal to 0, then P of X is equal to X minus G, and then times another polynomial. Another polynomial. Let me call this guy Q of X. Maybe I'll just write Q of X. A Q of X, and Q of X is a polynomial. I don't know. Do you know this theorem?
Yeah, briefly, like I learned about it. I mean, it's been a long time since I took like pre-calculus.
Let me just quickly say this. Now, if you look at number 4, on this theorem, then what we see is that let me just pull up my file. Okay, there we go. What we see is that we say in question 4, what you see is that one of the first condition is actually f of -3 is equal to 0. Now from here, what can we conclude? If now note that in this case f is a polynomial. In this case, what we're saying is f is a 4th-degree polynomial.
Mm-hmm.
Okay, so f is a 4th-degree polynomial. Now, one of the first condition is f of -3 equals 0. So what does that mean? What is the conclusion because from the factor theorem? This means that f of x will equal x plus 3, and then times q, and then times some polynomial. This is what it means. What that means is f of x plus 3 must be a factor of a polynomial.
Okay.
So why is that? Generally speaking, if f is a poly, divide f of x by, let's say by x plus 3. If f of x divide x plus 3, then what we get is this. Then what we get this. Then what f of x is equal to x plus 3, and then times q of x. Q of x is actually for quotient, and then plus remainder. When you divide any polynomial by fx plus 3, then this is what we get. Divide fx by x plus 3, then the quotient will be 3 q of x, and then the remainder will be r. But in this case, and then by the way, this r right here, it turns out this r actually is the same as f of -3. This r turns out to be f of -3.
Okay.
When you